Welcome to Cycle 2, first quarter, science. We are going to go over first quarter, science. We are going to go over all of the science experiments for the first 6 weeks of CC. So what you're going to need is your Van Cleaver's 201 Awesome, Magical, Bizarre, and Incredible Experiments, and your Foundations Guide. And hands-on science starts on page 188 for cycle 2. Then we also are going to have for you, Cornerstone has done some printouts for every single cycle. They have a lot of really good pictures and examples and stuff in here. So this will be a source. And then if you really liked Nicole Liam, she has the first 6 weeks of science on CC Connected. And she has the great questions to go along with the scientific method. And again, there's other resources on CC Connected. So what I'm going to do for science is I'm going to stick to the Foundations Guide and to Van Cleaver. And then we will provide you with the Cornerstone printouts and anything else you find on CC Connected. And you can tweak them and kind of make them your own within the structure of the science experiment that we're doing. So we're going to jump into week 1, which week 1 we're going to head outside. So how that's going to look in our community is that we have 6 classes. So we will have 2 classes go at a time, and I will let you all know which class is going when, and you will go outside to do the thermometer and the rope one. So let's go. All right, so we are outside, and in the Van Cleaver's guide, this is experiment number 2. It's called Shaded. So the purpose is to demonstrate how a planet's surface temperature can vary. So I have 2 thermometers on the same surface, one's in the sun and one's in the shade, and 2 more thermometers on different surfaces, one in the sun and the shade. So we're going to look at those temperatures. So the procedure is just to read and record the temperature on both thermometers and then discuss what you find. So you can ask the kids, go through the scientific method. Here's our procedure. Here, what are they? The purpose, the materials, the procedures. What's your hypothesis? What do you think we're going to find? So we'll go ahead and look. Here's one that is on my driveway. And you can see right now. All right, so now it is actually, gosh, look at that. It went down when the cloud came by. It's about 104 degrees outside here in the sun. And then the other one is in the shade over here. And this one in the shade, wow, look at that. It's like 98 degrees. Can you see? There you go, 98 degrees. All right, so then you can talk about why the temperatures are different. How big of a difference, and then the next 2 are in the grass, so we'll go check. All right, so this one says in the grass, in the sunlight, 104 maybe. Okay, and then we'll go look at the one in the grass in the shade. All right, so the one in the shade actually shows us like 99 or 100 degrees. Get a little friend there. So it is a little bit cooler, maybe even 98 in the shade over here also. All right, and so in our community, I will have the 2 thermometers already out for you. And as we rotate the classes, I'll let you know where they are, and you can go and look at them and record your findings. And then week 1, we have 2 science experiments. So the other one is number 17. All right, so this one, we're going to determine why satellites appear to be stationary. And again, this is where the Cornerstone or Nicole Liam will come in really handy, because it will explain more than Van Cleaver does. But our material, I have pre-cut rope for you that is 3 yards long. So you need a helper also. So I have Vanessa, who is going to help me. All right, so the procedure for this experiment is to be in an open area, so we will be outside to use, or you could even be in the lunchroom.
and use a stationary chair. So we'll talk about who's going to do what where. It says to use a tree or another object to represent the earth. We have a chair here, so this is going to represent our earth. Ask your helper to hold one end of the rope as you hold the other end. So you go that way. I'm going to stand right here on next to earth, and you're going to go way out. Walk at a pace that keeps the rope tight and in a position that you are in line with the same point on the tree as your helper. So this is what it's going to look like. Vanessa, you're going to start to walk that way, and I'm going to rotate very small, but we have to keep this tight. So go ahead and start walking. You can go a little faster. You're going to end up going a lot faster than me. All right, and that's all that experiment is. So the results are that the person on the outside circle moves faster, but stays in line with the same person who's moving in smaller circles around the earth. And then it goes into why and the planets. And there's some vocab terms and stuff that you can use, but that is what the experiment looks like. So now we'll go back inside for week 2.
All right, we are back inside, and I want to mention in your Foundations curriculum on page 129, we have the scientific method discussion, and the terms are different, a little different than the Van Cleaver. So first we're going to ask the question, look around you, what questions do you wonder about, the research, so this is going to be what materials you need, the procedure you're going to be doing, what is your hypothesis, what do you think the results are going to be. Then you do the experiment itself. You're gonna, and the analysis is the results section, and then you have your conclusion. Was your hypothesis correct or incorrect? And if you don't have time to go on to CC Connected, you can just follow this guide for your discussion time, because for the weeks that have 2 science experiments, you'll have 15 minutes for each. And you also have the Cornerstone handouts that we're going to hand you. And if you read through those experiments, they have really good information. They have vocab terms that you can go over. And some of the weeks even have really good pictures in this handout. So you can use as much or as little, or just the discussion guide if you'd like. So going into week 2, and we are on experiment number 24, which is called Mirage. So the purpose is to determine why the sun's image is seen before sunrise and after sunset. All right, so our materials are going to be modeling clay. I will have modeling clay already shaped for you. We have a bowl that you can see through. All of you will get the same bowl. We have a coin, which we're going to use pennies, and a pitcher of water. All right, so this is what this experiment is going to look like. So I'm just going to follow the procedure here. It says press a walnut-sized clay into the center of the small bowl. Stick the coin in the center of the clay and press down. Okay, so there's that so far. Now it says place the bowl near the edge of a table. Stand near the table so that you can see the entire coin. Then slowly move backwards until the coin is just barely out of sight. Then ask your helper to fill the bowl with water. So this is a master project, so you're only going to be doing one, but because we're using modeling clay, you could do it over and over. If you have 8 students, maybe do 2 or 3 students at a time, and have your bowl at the side of the table, have those students back up, each one of them at whatever angle that they're at, they can back up different places. Okay, so Vanessa's going to be my helper, and instead of backing up like the instructions say on this, we've decided that she's just going to lower herself until she no longer sees the penny.
It's like right here.
And again, you can have 3 different kids standing around the corner of the table and they all lower themselves so they don't see it anymore. So go back where you can't see the penny, and then I am going to add water. So you can't see it?
No.
Okay, stay right there. I'm going to add water until the penny is covered. Now can you see the penny?
Yes.
So did it rise? Did it get higher or did it get lower?
I can see it like it's a reflection on the top of
You
the
can
water.
see its reflection. Okay, that's great. And so if you only have 2 students or 3 students, then dump the water back in and do this experiment a couple times for each student so that they can have their own experience of seeing it. And the result is the coin is visible and appears to be in a different position in the bowl. And then why is the light from the coin changes directions as it leaves the water and enters the air. This makes the coin appear to be in a different place. This change of direction of light is called refraction. The Earth's atmosphere refracts light in a similar way, causing the image of the sun to appear before the actual sunrise above the horizon at sunrise and lingers after the sun moves below the horizon at sunset. And you can have probably lots of discussion because many of the kids, if not all, in your class have seen a sunset before. And you can just encourage them that next time they go to see a sunset, that when the sun actually disappears, you still actually see a little bit of the sun. So that is the first experiment in week 2. All right, the second experiment on week 2 is number 26, called distortion. So the purpose of this is to determine how the atmosphere affects the viewed shape of the sun. Materials are a pencil, a sheet of paper, a compass, and a magnifying glass. Some classes will have these, some might have this, depends on how much. I think I have enough. The students might have to share these, but I think these are going to work better for this project. So for the younger classes, I'm also going to have little erasers on the bottom of this. It should still stay in the same place as they're drawing their circles. The little hands might need help drawing the circles with these though. So you'll have to ask for mama help in your classroom. All right, I'm going to loosen my pencil up. I'm going to draw, it says in the procedure, in the center of the paper, draw a 1-inch circle in diameter. All right, so I'm going to draw my circle. Oh, that's much easier if I spin my paper. Ta-da! There you go, spin the paper, not the compass. All right, so I don't know if you can see that. There's my circle. And what I'm going to do is I'm going to take my magnifying glass and I'm going to hold it over my circle so I can see the circle, and I'm going to move it. Here we go. I'm going to move it back and forth. So I want to show you what this looks like on the camera. So there's the circle. There it is in the magnifying glass. Can you see that okay? How the circle is changing. So that's a lot of fun. We're gonna draw their circle, they're gonna play with it. They might think it's really cool. They can, you can go through your questions that you have for them. Again, we're talking about refraction like we did with the water and the penny, and talking about the Earth's atmosphere. They kind of relate. They're just 2 different science experiments. So again, I'm showing you the basics of each experiment. And then as you're reading through the Cornerstone paperwork, which has a lot more information in it, and as you're reading through anything else you find on CC Connected, make sure you're keeping it to your 15 minutes and asking a lot of questions and making the kids think so you can tweak it however you would like. All right, so for week 3, we're going to be doing experiment number 9 called See-Through. This is a very fun one, and there is only one experiment for this week, so you have 30 minutes to do this whole thing. Materials are scissors, a ruler, the poster board, glue, which we will have Elmer's glue, tacks, a pencil, and a Sharpie. So depending on what, for the younger classes, cutting 3 per student out on this and measuring the sizes and everything might take you longer than the 30 minutes because we do have very full classes. You'll have 8 students to do that with. So if you want to pre-cut that, the older classes can probably handle that on their own. Measuring with the ruler, it goes through and gives you all the directions here. Cut 3 strips of poster board that are 1 by 6. So 1 inch here by 6 inches here. And then 1 inch and 6 inch. So you're going to cut 3 of those strips. Evenly space the strips so their centers are a cross. So it kind of looks like this. So you'll evenly kind of make a little circle out of them. And then it says glue the centers of each strip. So I'm just going to do this right here in front of you. All right, so now they're all stuck together. It says use a marking pen, which is your Sharpie, to make 2 marks across the ends of the strips. I've already done that for these. These are leftover from last time we did this cycle. So I pre-drew the strips, and for the little ones you could have that, and then they can just kind of color each one in. So you're gonna wanna color the little sections each in and make each one of them completely black. The older kids will have time. I have Sharpies. I don't know that I have enough for every single student. So we might have to use just markers, like black markers for some of them. So you'll go around and you'll color these in or draw them and then color them in. And once it's completely finished, the next step says, ask an adult to insert a pin through the center of the strips. So you're gonna take your pin, so they're flat on one side with the pin, and you're gonna push it kind of right through the center, like so. And then you have the nail on the other side. And then it says to stick the end into a pencil eraser. So I'm going to just stick that right into the middle of my eraser, like so. So now there's your finished product. And then it says spin the paper blades, observe the spinning. So now they'll spin it like this, and if it's all colored in black, these circles will look, you'll be able to see through them. I don't know if it, oh, you kind of still get that effect. So I don't know if you can see as it's spinning where the black lines are, you can kind of see right through it. That is this experiment for this week. This is a project that if they would like to take home, they are welcome to. But as a tutor, I would hold on to them and hand them out to the parents at the end because I don't want the kids taking the nails, the pins out. And as I'm going through all these experiments, if you have any questions, please write them down. And in our tutor meeting, we will discuss, we'll go through and see if you had any questions about any of these experiments. So for week 4, we're gonna move on, and we have experiment number 4, which is called On the Move. So for this one, our materials are a round cake pan, a marble, scissors, some construction paper, and a pencil. Okay, so here are our materials. The procedure says, use the cake pan to trace a circle on the paper. It's gonna lay in the center, so we're gonna trace the smaller circle on the bottom. This is a master project, so you as a tutor, as you're doing this, you'll do this just like I'm doing it for you in front of your class. So then we're gonna cut our circle out. Okay, so there's our circle. So now it says, place the pan on a flat surface. Lay the paper inside the pan. So it looks like that. And place the marble on top of the paper. It says thumb the marble so that it rolls around next to the wall of the pan. So I'm just gonna kind of spin it. Okay, I'm gonna give it a better spin. There we go. So it's rolling around on the edges of the pan on top of the construction paper. Now it says remove the paper from the pan, and again, spin the marble.
And the results should be that the marble rolls in a circular path. It rolls faster and faster without the paper lining in the pan. So if I spun this, it seems to go a little bit faster than when I had the paper in here. It definitely slows down faster with the paper. So you could have the kids each take a turn and pass this around, but we're only gonna have one of these. And the word that we're defining is inertia. It's the resistance that all objects have to any change in motion. It causes stationary objects to remain at rest and moving objects to continue moving in a straight line unless some force acts against them. And so you just ask a lot of questions. Remember always, before you do the project, ask them what they're gonna find. So now that you know what the project looks like, you can say, here's our materials, here's our procedure. When I put the paper in, do you think the marble is gonna go faster or slower? When I take the paper out, do you think the marble will go faster or slower? And again, there's a lot of ideas on the Cornerstone and on CC Connected. So that is the first one for week 4. And the next one is right under it. It's number 12. It's called Speedy. So the purpose here is to determine the effects of distance on orbiting speed of planets. Our materials, we have a washer and a 1-yard piece of string that is already pre-measured for you and already tied. So note, this needs to be performed in an open area. So as you're doing this in your classroom, if your classroom is too small or too tight, you can go outside. And you as the tutor, use discretion. If you have older students, they could probably each take a turn trying this. The younger ones, if you have parent help, they could probably try taking turns, but please make sure there's no other kids around when they're doing it so nobody gets hurt. So the procedure for this is to tie the washer to the end of the string, to hold the string and extend your arm out this way, but I'm gonna do it over my head for the sake of the space that I have here. When you're doing it outside, they just hold their arm out and begin to spin it that way. Swing your arm around so that the washer moves in a circular path next to your body. And in my case, on top of my body. So it's running or going in a circular path. Hold the string in the center and spin the washer at the slow speed necessary to keep the string taut. So this is at the very end, and then if I want, I can hold it halfway through. This one I can do right here. So there it's spinning, and I can try at the slowest speed possible to keep it spinning so that the string is taut. It keeps wanting to change. So again, that's why when they're doing it, make sure that nobody else is around. And when you're showing them, make sure the class is standing back and you have parent help in your classrooms to make sure nobody runs up and wants to try before their turn. So then you just talk about the different speeds when you hold it from the center or when you hold it from the end, how the length of the speed decreases. So if I decrease the length of the string, then the washer must be spun around more times in order to keep that string taut. So again, to show you, if I hold it from here, I don't have to go very fast. This is about as slow as I have to go to keep it still moving and keeping the string taut. But if I hold it here in the middle, I actually have to go a little faster to keep it moving. All right, and then you can read the why and have a discussion on that. And I have 1 washer and string per classroom. So for week 5, we're going to be experiment 13 called expanding. This is a fun one also for the kids. It's going to determine how galaxies may be moving. Our materials are a 9-inch round balloon, a black Sharpie, which the students will have to share, and a mirror. So our procedure is to inflate the balloon so that it's about as large as an apple. Okay, so that's about the size of an apple. Holding the air in it, you're going to mark
the balloon randomly about 20 dots on the balloon. So just random.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay. 19, 20, right? 20. 19, 20.
There are our 20 dots on an apple-sized balloon. Now, stand in front of a mirror and observe the dots as you inflate the balloon. So now I'm gonna blow into it, looking in my mirror. So you might have to do teams of 2 with this, maybe teams of 3 and have them take turns. Everybody can do this part, but they'll have to share the mirror. Maybe as one person's going, the next person can be drawing the dots on their balloon if there's not enough Sharpies for each class. So I'm going to look at my mirror. I'm actually going to do this so that you guys can see in the mirror also. My mirror really should be cleaned. There we go. So now in the mirror, I can see what's happening to all of my dots. To you guys, the camera is your mirror, and you can see what's happening to all of the dots on my balloon. The results are that the dots are moving away from each other. So further out here, the dots are further away than the ones that are closer up. As I continue to blow this balloon up and this gets bigger, these dots would move further away. And this is for every student in the classroom. And then you're gonna discuss the why. Astronomers believe that the galaxies, which are large systems of stars, are moving away from each other, similar to the way that the dots on the balloon moved away from each other. So these, when I drew them, were a lot closer, and as I blew, they moved away from each other. And you can go through and you can just talk about that. It also talks about Dr. Edwin Hubble. You can have a discussion about if anybody recognizes that name, what he invented. He invented the Hubble telescope, which we use to study stars and galaxies, which is beautiful and amazing. When they're done, you can throw the balloons away. They'll want to keep them, and I'll let that be tutor discretion, but as you can see, I'm already messy. So, in my opinion, throw them away. All right, so moving on to the next one. Again, remember you have 15 minutes to go over each experiment during your science experiment time. This is a new experiment this year. So this is the first time for all of us doing this experiment. The purpose is to demonstrate the force that it takes to keep satellites in orbit, which is very cool, I think, in my opinion. So I'm excited to do this experiment. You will need scissors. I'm using my scissors. You will have scissors in your bins. You'll have a master scissor for you as tutors, a bigger one, and smaller one for your students. So those will be in your bins each week. A yardstick. Christina, could you please find me the yardstick? Thank you. Some string, masking tape, thread, spool, and a metal spoon. So Christina, you know what? Sure, thank you. If you have a yardstick and you want to bring it in for your class because this is part of the procedure or the materials and the procedure, you can do it. Otherwise, you have rulers. We have rulers in our cabinet. You can grab a ruler and explain that this is 3 of these long is a yardstick. If you want to incorporate that into your materials and procedure, but I will have this string pre-cut for you. So it just says to make the string the length of a yardstick, use your scissors to cut your string. It says tie one end of the string to the roll of tape. This is a master project, so each one of you will have 1 roll of masking tape. I do need these rolls back because we will be using them again for a couple different experiments this year. So we tied that. Thread the free end of the string through the hole in the spool. So I bought these cute tiny little spools. Okay, so you have to thread your spool. That was a little difficult. I had to spit the end of mine. So keep that in mind as you're doing this project. Okay, and then you are going to tie the spoon to the free end of the string. I'm just looking at the picture on how to tie my spoon. I'm gonna make sure that it's nice and tight so that when I do start to spin my spoon, it doesn't fly off and hit somebody. Okay, so I tied it the lower end so as it pulls up, it's nice and tight. Okay, so now, so stand in an open area, holding the tape in one hand and the spool with your other hand. Okay, so I have to hold the tape in the spool. Give the spoon a quick circular motion to start it spinning in a horizontal circle above your head. Release the tape and allow it to hang freely. So I'm going to use my right hand because I'm right-handed. I'm going to get this started. I'm spinning that. All right, and I released the tape. See, this is why I do this for you guys, so you can see, hey, you might hit yourself in the head with the spoon or hit yourself in the face with the masking tape because my spool was moving a little bit. So that is how it looks. The results are that the spoon spins in a circular path with only the weight of the tape pulling the attached string. So as that's spinning, I was only holding the spool, but the spoon was able to still spin because of the weight of this masking tape at the other end. I could keep it going with just holding the spool. Any circular object, a spoon or a satellite in orbit in outer space, has centripetal force, which is force directed toward the center, keeping it in a circular path. Moons that orbit planets and planets that orbit the sun are pulled toward the celestial body that they orbit. Their own forward speed keeps them from being pulled into the body that they are orbiting. And the centripetal force acting on the orbiting bodies keep them from moving off into space. For week 6, we have 2 experiments. They are master in that there's one lamp or one flashlight for the second one, but each student can take a turn doing them. So for number 3, it's called Cover Up. You will need a desk lamp. I have one desk lamp. So if any of you have a desk lamp that you can bring in, that would be great. If not, then I can post something on Shutterfly and see if other families have a desk lamp that they can bring in. Otherwise, you can just use one of the lights. So we'll talk about that in our tutoring meeting. But for now, this is our only material. So the procedure I'm going to read to you before we do this, and then I'm going to get up and show you through the camera so you can see it in action. It says, stand about 2 yards from the desk lamp, close your right eye, and hold your left thumb at arm's length in front of your left eye. Your left thumb at arm's length in front of your left eye. Slowly move your thumb toward your face. So you're going to hold your thumb in front of the light, and then you're going to bring it to your eye until the light disappears. So this is what it looks like. And the purpose is to determine why Mercury does not cause an eclipse. So you can define what an eclipse is, and I will show you right now what this experiment looks like. All right, so I'm coming down here to you. So you're gonna be me. So we're gonna hold our thumb out. Okay, so the light's not covered, but as I'm bringing it toward me, you can see that now you can't really see the light at all. So that same effect can be had with a desk lamp or a light, a lamp or a light on the ceiling. But that's what that experiment looks like. So that was very quick. You have 15 minutes to do that. If you have 8 students in your class, it will give you lots of time for explaining what is an eclipse and why are we talking about it using this desk lamp. So the thumb blocks the light moving from the lamp towards your eye.
The closer your thumb is to your face, the more light that it is blocked. Because Mercury is very close to the sun, it blocks only a small portion of the sun's light. If you would like to mention at this point, in the next quarter, they're going to be making a very large solar system outside and a very small one inside. And if you mention it now, when you're doing it then, you can say, look, now do you see how close Mercury is to the sun? And that is why Mercury doesn't cause an eclipse, because when my thumb was way out like this to the light, that's the size of Mercury to the size of the sun. That's why it doesn't cause an eclipse. And so you can have more discussions about what a solar eclipse is through your other materials. So the next one on week 6 to end up our first quarter is number 4. It's called thick. The purpose is to determine why Venus's atmosphere is so hard to see through. So last week, on week 5, you would have maybe talked about who Dr. Hubble was and the Hubble telescope. And you could maybe even find some pictures of Venus online if you want to print them and bring them with you, or there can be some in the cornerstone handouts that we gave you. Nicole Liam might have some on hers. So you'll have other options where you could bring in a picture so they understand what you're talking about here. Okay, so your materials for this one are a flashlight and wax paper. I will have wax paper for you. I'll hand it to you that morning. So it will already be pre-cut for you. And this is the one week that I'm going to ask you if you have a desk lamp or a flashlight to bring them in, because I don't have 6 of those items. And it would be foolish to spend all our supply money on that. So if you can bring in a flashlight this week, these are our only 2 materials. The procedure is turn the flashlight on, place it on the edge of a table, and in this case, I'm just going to hold it for you and then put the wax paper in front for you. But in your classroom, you would just set it on the edge of the table. So I'll show you what it looks like, and then I'll show it to you so you see what they're going to see. Stand about 2 yards from the table. Face the light and observe its brightness. It's going to be very bright, especially if they look right into it. This is a great time also to go through your hypothesis and ask your questions of what they think they're going to see. You're going to hold the wax paper in front of your face and look through it at the light. So this is what they are going to see. Here's the flashlight. If you hold the wax paper, you can see how kind of blurred it is. All right, so the result is that the light looks blurred through the paper, through the wax paper. And the reason why, which would be your conclusion, the light rays bend and bounce off of the wax paper. This is similar to the way that light bends and bounces off thick clouds that surround Venus, which are not particularly dark, they're just very thick. In their thickest part, the visibility is about 0.6 of a mile or less. This low visibility would result in the closing of most airports on Earth. So that is why it's hard to see through Venus's atmosphere. And again, in this, they have little pictures for you. So that'll be fun. Each kid can stand in front of the flashlight and hold the wax paper and look through it, and you can have discussions. Week 6 is simple, but nice for the end of the first quarter. So if you have any questions about any of this, write them down, bring them to our tutor meeting, like I said, and bring all your sources with you to our tutor meeting, and we will go through any questions you have. So thank you very much.